right, welcome everybody to this webinar regarding leveraging 3D scanning technology in reverse engineering. I'm going to first go through a quick PowerPoint, and from there we'll get into the actual scanning and reverse engineering of our parts. All right, so first off, we're going to go through some quick case studies of actual projects that Creaform has done in reverse engineering, and then move on to the products and get started with the reverse engineering. So first off, they've done some reverse engineering, creating the CAD model of Boeing jets in the Boeing nomenclature, scanning all external components of an aircraft engine so that the CAD model can be created and then inserted into an assembly, designing and creating specific tooling, engine tooling. This one is interesting. It's scanning and reverse engineering the inside of a cockpit. Especially with traditional methods, this one would be very difficult with all the tight spaces and all the small equipment that's everywhere and throughout the cockpit. Also, another interesting one, doing scanning the entire outside surface of the project dash so that it can be digitized for volumetric analysis. So again, again, an interesting project and an interesting application that's a little bit different from the norm with reverse engineering. I'm just going to go through a quick overview of all of them on this slide. These are the product line of Creaform. Most of you are probably at least somewhat familiar with this. So just as a reminder, the Go Scan is primarily for reverse engineering with an accuracy of 0.004 of an inch. It also brings in the ability to scan color and texture and use that as its references, so it doesn't always need to have the tracking targets. Both the Handyscan and the Metroscan have an accuracy of 1.2 thou, so much higher accuracy, and this is where we start using the scanners more for inspection as well as reverse engineering. The speed of these is also much faster than the Go Scan. We also have a Handy Probe, so a completely portable CMM that is wireless, so you can create all of your entities using the Handy Probe as well. You can robot mount either the Handyscan or the Metroscan if you want. Put that on a robot arm to complete scans faster. The MaxShot is our photogrammetry solution. So if we're needing much higher accuracy for larger objects, and this is for larger than 6 feet, we can actually bring that accuracy down to 0.5 thou. So increasing that accuracy dramatically. Also, I forgot to mention the Handy Probe has an accuracy of 0.8 thou. And then our V-Track allows us to track dynamic motion as well. So just a little reminder as to what each of the items in the product line give us. Let's go ahead and talk about scanning. So a lot of times in Hollywood TV shows and movies, we see things where it goes from being a very easy scan to all of a sudden, boom, you've got your product. You've got in this case, your armor, your costumes. And this is not the case in real life. There are some easy ways of doing things, but for the most part, we're going to see that it does take a little bit of effort and a little bit of work. This is the basic workflow, though, for reverse engineering, and I'm going to go through both methods. So we're going to start off with our scan. This will create an auto-generated mesh. We're not going to deal with point clouds at all. It's going to entirely be mesh files, which makes it a lot easier for us to handle and use. Once we have that mesh, we'll create an alignment so that the origin is in a place that makes sense. From here, we'll improve our mesh, and so that we can smooth out edges, get rid of holes that might have been in the mesh, things like that. Once we have our mesh improved, we have two options. We can either do scan-to-CAD or scan-to-3D print. We'll go ahead and talk about each of these two methods. So if we go scan-to-CAD, what we're going to do is we're going to be creating entities, cross-sections. So we're going to be creating things like planes, spheres, cylinders, cones, the cross-sections, all of these things, and we're going to take these entities and bring them into our CAD platform so that they can be used as guides to create our final shape, our final product. And so again, this can be somewhat of a lengthy product or process, but we start with an imperfect manufactured part, and we end up with a perfect CAD model with a full feature tree. As opposed to the scan-to-3D print method, we're going to edit our mesh and refine it until we get it to be a watertight mesh. Once it's watertight, we can then save it as an STL file and send it to the 3D printer. We can also use this method to do an auto surface over that watertight mesh and send that surface into SolidWorks, for example, and it'll come in actually as a dumb solid. So if we need something very, very fast and we don't care as much about the roughness, we just need a filler basically, this is a great option, but I like to call it the quick and dirty option because it's not a true reverse engineered process. You end up with a copy of your imperfectly modeled part, and especially things like your tight corners, you're going to have those rounded edges instead, and so it's not going to be the best file. It will be quick, however. And then as always, if you go the scan-to-CAD route, you can end up with your CAD file and then save that as an STL file and send that to the 3D printer. All right, but why do we reverse engineer things? These are two actual examples that I've come across when demoing scans or when demoing the scanners. I've scanned dinosaur bones. I've also scanned thrones like this that were made of solid silver, and you were not allowed to put any tracking targets. You're not allowed to put any sort of spray on there to make it so it scans easier. In that case, that requires the Metroscan to deal with that shiny factor of that solid silver. But so there are some things like this that are for more museum type issues. But the biggest reason that most people use scanners is because you do not have CAD data. Whether it's for OEM parts and the OEMs do not want to share that data, or maybe the CAD file never existed and you've got a 50-year-old die in your factory that hopefully will never break, but if it breaks and you don't have that CAD file, then you're going to have to find some way of recreating that part without the original die. And so again, these are some reasons that I've noticed that people are buying scanners for. Before we get into scanning, let's talk about some tips. Now, if we look at the two columns, I don't know what plane 1 is. I don't know what circle 7 is. I don't know what those things are. But if I look at the example on the right, that's much more easy to understand and recognize what those things are, especially if I'm the only one, if I'm the one that's the main person that's in this project. And so again, this will just help you, naming all your entities will just help you to understand where everything is and what's going on. Another important thing is to use constraints. If you have two planes, if you create two planes and you want them to be parallel, make sure you make them parallel because the scan data might not actually do that. They might be slightly off, and a lot of times they will be slightly off. And so it's important to make sure that you do use those constraints. Or for example, if you have two cylinders and you want to make sure one cylinder that they share the same axis, that's another constraint that's very useful and good to use. I also prefer to transfer entities in small groups. As you can see here, it has a direct transfer to SolidWorks, Inventor, and Solid Edge. If you have any other CAD platform, you can save all the entities off as an IGES or step file and bring them in. So it's still possible to do it. It just takes, you have to create all of the entities and then save it as opposed to doing it in small groups. I like doing it in small groups. That way I can focus on one part of my CAD file and then move on bit by bit as I'm going. All right, let's go ahead and get to scanning though. I will be using the Handyscan 700. All right, and here's the part that I'm going to be scanning. This is a demo model for our 3D printers. That we can use this. It's for showing how to hydroform parts using 3D scanned or 3D printed parts. Now on this scanner, I have some buttons on the back. These allow me to change my zoom and my shutter speed, so I can be hands off the computer and control all of that from my scanner itself. Also on the left-hand side of my graphics window, you'll see that I have that it's showing in red right now, that indicator bar. That's showing how far away I am from my scanning object, whatever I'm actually scanning. If it's red or yellow, it's meaning I'm too close. If it's getting into the blue area, I'm too far away, but it's still scanning regardless as long as one of those colors is showing. The green is the optimal speed, the optimal amount of information that it's picking up at any given time. Now the resolution on the screen currently is pretty rough. And that's because if we were to do it at a full resolution, or the resolution that we'll end up with, we'd be crashing our computer very often. So instead, I'm going to go ahead and, oops, don't want that, don't want to get rid of all that. I'm going to get rid of this last little bit down here and then let it process all the information. I currently have my resolution set to 0.039 inches, but you can increase or decrease that at any time. It always scans at the highest resolution, but you choose what you output whenever you are working with the scan. And I can change that at any point, either before or after the scan. Now that I have it from this orientation, I'm going to choose to add a scan, and then flip this over so I can then scan the opposite side. This will allow me to bring in information from both sides and have a fully complete part when I start my reverse engineer process. This one is completely flat on the top, so there's not much to miss, but this way I do get the most complete picture and the most accuracy out of my reverse engineered part. And so that bit was a really nice quick scan. Again, I'll edit it and get rid of everything that's not the actual object that I'm interested in. And then let this one process. All right, now that I have both sides, I'm going to go ahead and choose to merge the scans. Now, since I do not have targets on just the object itself, I do need to use my surface best fit as opposed to target best fit. If I only had the targets on the object itself, I could do target best fit, which does the entire alignment for you. So in this case, I'm going to do a pre-alignment, and I want to make sure that I'm choosing the same areas. I'm going to make sure my orientation is similar. There we go. I'm going to choose 3 points. They do not need to be exact, but I do want to be pretty close on each of my scans. Once I have that, I'll hit align, verify that it looks good. Looks like that looks pretty good. Hit accept, merge, and now I have one scan that has all the information in it. I'm going to go ahead and turn my webcam off. And we'll focus now on reverse engineering. First off, I'm going to hide my earlier scan. So I'm concentrating only on the complete scan. And I'm going to send this over to VXModel, our internal module for reverse engineering inside VX Elements. Now before I do anything, I'm going to clean the mesh. This will improve the mesh by getting rid of isolated patches, spikes, filling in small holes, getting rid of narrow bridges. There's not a whole lot of issues with this file, but there are some. And this is a really nice automated tool, so you don't have to go through and try to pick and choose everything. And then once we have that done, we can go through if there's some other small holes. Looks like we have one over here. We can go ahead and fill that in. Now again, you can see that it did kind of blend all that together. So I can undo that and do a partial one. Let's start off with the flat one on this side. And then fill in the rest from there. All right, that leaves me with no more holes. So that's one way of checking that I have a watertight mesh. Another way of checking is to look at the mesh properties. I can see here that yes, this is watertight. All right, before I do anything else, I want to create my alignment. Now, if I just want to get the origin somewhere approximately in the center of my object, I can set it up to use that alignment. And we can see here that it is somewhat in the center. But what if I wanted to have it based on that top face right here? I'm going to go ahead and back out. There we go. Let's bring this back over. I'm going to create a plane along this plane top. And from there, I'll use that as part of my alignment. And reverse that. I can choose which direction I want that to be. I'll go ahead and leave that where it is right here. Hit align, and now I'm good. Now my origin is at the center approximately of this face. Before, my origin was at the location my scanner was when I first started scanning. But now that I have this here, I can start to create my entities so that I can create my full design. So I'm going to start off with a cross-section. With this, I'm going to use this based off of the plane top, and I need to go the opposite direction, go down. I want to go about halfway down to make sure there's nothing interfering from any of the edges. I'll hit create and close. Now also, I want to use cylinders. I'm going to create a cylinder on the inside face and the outside face. The reason I'm doing this is this way I can set the cylinders to be on the same central axis, which will allow me to have a little bit more exactness in my edges, on those outer edges. All right, I'm also setting it so that the cylinder is normal to my plane that's on the top to give me a little bit more accuracy to that. I can also adjust my diameter if I want. I'm going to leave that for later though. Actually, I'll just go ahead and say I want that to be 4.55. No, apparently it thinks that's too big of a change. We'll go ahead and I'll adjust the diameter when I get back into SolidWorks. So I'll go ahead and create that on that side. Cylinder 2 will be on the outside. And this time again, I want to make sure I have the same central axis as that cylinder 1. I'm going to go ahead and call this outside. And to make sure I get this correct, I'll go ahead and rename that one to be cylinder inside. Once I have this, I'll be able to go through and now transfer these entities into SolidWorks. I already have SolidWorks open, so it's not going to have to open SolidWorks for me. I do not have any files inside or active in SolidWorks. So if I did have files active, it would place them in the active file, which I do not want. All right, now that I have this open, I want to get rid of the portions I do not want of those cylinders. I'm going to go ahead and use the delete face command. I'm going to just get rid of those 4 faces. Now I'm going to start a sketch. And we're going to make these 2 lines equal. They already are equal because of the diameter, so they're connecting to the center. But we're going to go ahead and create a new surface, or I'll say I'm going to trim the surface with this. And I want to remove these outer portions. So I'm only left with this inner portion right here. Now that I have that, a little bit easier to concentrate on this now. And I'll go ahead and convert my edges from the leftover faces and then start drawing in everything else. I'm going to attach this. All right, those are not going straight into the center, so I just wanted to verify to see if that would give me, or go towards the center of that same center. They are not. That's fine now. Let's see here. I'm going to add in a couple more straight lines. Use some splines as well. Use some tangent relation. I'm going to get rid of this portion I do not want. Oops, and that got rid of too much. There we go. And adjust these spline handles until we have the full design. Now this sometimes will happen with splines, I've noticed, where it's, once you add that tangency relation, it loses the handle, so you have to bring that back over. If you adjust the handles first, then it doesn't matter, they'll be there to stay. And since it didn't like that tangency relation, I'm going to instead set it so that the spline handle is tangent instead of the actual line itself. Or you can set them to be collinear. Alright, let's go ahead and do a corner trim on this corner. And we'll adjust our fillets so it fits what we want. That one right there looks good. Alright, let's add in another small straight area right over here. And we'll add in another spline. Again, adjusting the spline handles first, so when that tangency relation is added in, those don't disappear. That looks good right there. Do another corner trim. And this sketch fillet. That looks good. Now what I'm going to do in this case is I'm going to set these points to be horizontal, and I want them equal. And I'm going to adjust this back so that's where I want it to go. Looks like I'm going to need to edit that, or change that spline. I'll go ahead and trim it out and start that spline over again. Don't need it to be on power trim. Okay. Now the reason I set those earlier ones so that they were involved, let's turn that off until I get the shape on here better. All right. That looks pretty close. All right, so the reason I set it up so that those two lines were equal and had the points all defined so that they're horizontal, this will allow me to attach a line going from side to side. I'm going to make it a construction line. And then I'm going to use that to find a central axis. What this will allow me to do is I should be able to then mirror portions over from one side to the next, make this construction, so that there's less for me to worry about. And it looks like I did a little bit too much. Let's extend that down to the bottom. There we go. And again, make this one construction geometry. All right, so we're going to go ahead and use the mirror entities command. Mirror about this construction line. We can see here, everything is symmetric. Now, one thing I can do instead of having this all mirrored over, I can actually take this line. I'm going to leave it so it's no longer for construction, and I'm going to get rid of that other portion. This way I can do everything on one side and then mirror the other portion over so I can make sure that I have a perfectly symmetrical part. All right, before I can extrude this, I need to define a couple more planes inside VXModel. I'm going to go ahead and hide these entities. I'm going to call this next one plane middle. Set the orientation so it's normal to the original plane. I'm also going to create another one that's based off of the ends of my cones. And then a third one for these outside wings. All right. We'll go ahead and send those over to SolidWorks now. All right, let's go ahead and take that sketch that we just created. We're going to extrude this using up to surface. And I'm going to go to my plane middle command, the plane middle. This will give me the full shape right there, the main body. Now that I have this, I'm going to go and hide my surface bodies. I'll delete them later, and then hide my cross section as well. Now that I have this, I need to go ahead and create my cones, or the one cone that I'll be needing. Now in this case, I need to keep track of what is what. All right, so looking at the orientation of this, okay, so I'm wanting to create the cone that's on this portion right here. So again, I'll go up to my cone command, make sure that the orientation is set according to the plane, the correct plane. And I'm going to use my brush strokes to make sure I'm getting exactly the area that I want. And one thing I've noticed on this file is initially it thinks that I want to make some other plane that is the opposite direction. You can tell it's going in the wrong direction than what I actually want. So what I'm going to do is I'm going to flip the orientation. We can see that that's a much better angle. I'm going to change that half angle to 45 degrees. From here I'm going to say create, close that out, transfer that cone to SolidWorks. We can see that's there where it should be. Now for this, I'm going to go and hide my lower portion. I'm going to go ahead and hide my planes so that they're not in my graphics window. And then using delete face, I'm going to get rid of the upper and lower faces. I'm going to extend this down up to, again, my plane middle. Something about that it does not like. I'm going to recreate this. Using a plane middle instead of plane top. Well, it looks like I got a little bit too much. Let's try that again. Get rid of that information and then resend that cone over to SolidWorks. Alright, so again I'm going to delete the faces. And then I want to extend these. You may have noticed, you may not have, if I go ahead and bring the main body back. Oops, wrong thing. There is a slight gap in some areas for that between the main body and the cylinder, or between the main body and the cone. Let me go ahead and extend. I'll just go extend both of them 40.4 inches. And then I will use my planes to cut in through this. All right. Just going to use the exact same sketch basically for both of these. So I can use these as my trimming tools. There we go. And I'll choose to set it so it creates this all. That way I don't have to do any extra work involved. So if I bring back the original part, you can see that it's right on top of it. I'll go ahead and combine these two into the same body. And then I'll go back. Now I need to find a way to create these wings or these portions on the sides. What I'm going to do in this case, I'm going to do a cross-section. And instead of using a plane that's existing, because I don't have anything that's going in the right orientation, I'm going to instead find the correct plane that's based off my origin. That one's not going to do it. Neither will that one. This one, however, does. I'll go ahead and leave it right where it's at. And I will go ahead and transfer that second cross-section to SolidWorks. Alright, similarly, again, this cross-section is complete, but I only want to use it as a guide. So I'm going to start a new sketch on that same plane. And then just, again, so I have a bit more information, I'm going to use my intersection curve. That way I'm basing it off the complete CAD file that I have so far, instead of doing it wholly on the sketch itself. Gives me a little bit more information. Go back to going normal too. I'm going to go ahead and extend this downwards so that it goes all the way down. Turn off the portion I don't need. I want to make this line collinear with the plane that I created earlier. This way I know that it's perfectly in line. You can see that it's a little bit off of what the sketch originally says it should be. But this way it's taking into account the whole surface as opposed to just where that cross-section is located. Trim away again the portion I don't need. And then create another spline for this portion right here. Again, getting rid of the portions I do not need. All right, once I have this sketch right here, if I forgot about that tail, let's go ahead and trim that portion away. I'll go ahead and extrude this. Now, obviously, this will not extrude correctly if I leave it how it is. It looks like, let me go ahead and choose my area. So again, it's not going to go in the right direction unless I select this line as my guide. I'm going to go ahead and go mid-plane and move this out further than the actual confines of the object. And then I want to go back into my surfacing and do an offset of 0. And actually, I'm going to move this surface offset so it's before my boss extrude. That way it's not going to take into account the portions of this that's already part of that. All right, once I have this, I'm going to go ahead and hide the rest of my body. Extend that up. Hide that cross section just so it's not annoying me anymore. And I can use this surface now to cut away the portion I do not want. Cut away on the outside. And now I have this looking very nice, this wing looking just like I want it to be. I'm going to go ahead and get rid of everything but the solid body now. Get rid of those surface bodies. And then do a mirror operation on the whole body. This way everything is completely symmetric all the way through, both the wings on the sides and the two cones. And again, I could go through a little bit more in depth to make sure that my Positions of my cones are at specific locations using dimensions or using move copy bodies. But again, this is the basic steps I would want to take. And again, to make it a complete part file, I would want to define a material. But right here is our fully reverse engineered part. And again, starting from scratch from the initial scan. If you have any questions, again, please contact us on either our website or your local salesperson. We thank you for your attention, and we do have these upcoming webinars as well. So if you're interested in any of these topics, please register so that we can teach you more about these different topics. Thank you. Have a good day.